This week in organic chemistry, you're going to be working with the gas chromatograph, or the GC is what most people call it, so it's not as long. You have, in this room, we have 4 individual chromatographs, but because of COVID, we're going to spread out, or at least I think we are going to spread out. Each one is technically supposed to be equipped to do 2 things at a time. You could have 2 people work on either side of the injectors, but most of the time we have 1 injector for each, just for simplicity's sake, I suppose. And then in between each one of these chromatographs, we have a computer. So there's 2 here and a computer, 2 there and another computer, and the information is fed to the computer when you take the chromatograph. So ideally, all of this will already be on before you get to lab. Each one of these will already be like activated and hot and ready to go, and all the computers will be set up and ready to go. And so this is what it looks like. This is what you'll see when you come in here. There are 2 individual screens for acquiring data. And they're normally just named Channel 1 and Channel 2. And so in this case, Channel 1 pulls information from this chromatograph, and 2 pulls from this one. And so what we'll see over here is whenever you run a GC, you'll have you over here associated with this, and then you'll have probably a lab partner that's working on the computer, and then you'll inject your sample, and then you will take your information on the GC. If we have in here, we already have laid out papers. We have 2 individual instruction sheets. They have GC instructions on the front, and then just instructions for the experiment on the back. Pretty simple, pretty straightforward, but I'm going to go ahead and go over them. The good thing about this is because all of it is previously done, about half of the information is satisfied before you even get to lab. You will start right after it says you are enlarging a channel to full screen. And so this is what is already set up for you. You'll come in here, and the first thing you'll do before you start running a sample is you're going to hit check baseline. If it's not already selected, it will look like a standard, Windows 7 button that's coming out of the screen. You'll click it, and it will look like it's indented, and then at the bottom, it will say that it's checking the baseline voltage. And this is for the calibration of the GC. You have to do this first. When this is on, this number down here will appear and start updating. In this case, it's already been checked. We checked the baseline a minute ago, so it's already been adjusted. But in this case, we'll pretend that it's not. It's updating, so we'll hit 0 adjust to re-zero it down to the center. And then once it's ready to go, we will uncheck the check baseline and make it look like a regular button. And of course, when you've done this, it stops updating the numbers down here, and it's ready to go. And so on this page, you are now all the way down to sample run. Now, to actually inject a sample into the GC, you're going to be using a special kind of syringe called a micro syringe, and it's just like a traditional syringe. It's very sharp on the end, like you'd be getting a needle from the doctor's office. So to be very careful when you're working with one of these. These are made for picking up very, very small volumes of liquid. In fact, I believe this is rated to 10 microliters. Yes, it is. And so it only picks up a very small amount. So I've got my stuff ready to go. Now, supposing I wanted to inject a sample into here, in this case I'm working with hexane, so we've got plenty to work with it. One of the biggest problems we see with working through one of the GCs is that we put stuff in there, at least we think we do, and then the GC shows nothing when it comes out. It just has a flat baseline, and then everybody freaks out. But one of the first things we suspect is that these microsyringes are no good anymore. Either the tip has been clogged by a piece of rubber from the septum that's on the inside of the GC, or maybe the needle is slightly bent, and so it's not actually picking up any volume. Because it's so small, you won't be able to feel any resistance with the plunger and notice if it's been plugged on the other end. So you're actually going to have to check yourself. So in this case, I'm going to pull up some hexane in here to verify that this works. You will do this for rinsing anyways, as you will find out through your procedure, but I'm going to go ahead and verify that this one still works. I pulled up some hexane, and now I spritz it onto the chem wipe, and the chem wipe is now wet, and I can verify that there was liquid inside of the syringe. So now, I shouldn't have to worry about that in particular unless it clogs on this particular run. But for now, I know that this syringe is working. So now, suppose that I've got my stuff ready to go. I have nothing in there for now, but you will have it, and it will look something like this with your liquid on the inside. And let's say that I'm ready to go ahead and run the GC. So I'm going to use this one for the example, and I'll be running it to channel 2. So as normal, I check the baseline, 0 the voltage, and then uncheck the baseline. And then now let's suppose that I have this ready to go. When this is actually activated, this right here is where you're going to be injecting your fluids into, and this is a piece of metal. Now, gas chromatographs are heating up the stuff to the boiling point, so they're extremely hot on the inside, and since this is metal, it's conductive on the outside too, at least thermally conductive. So this will be very, very hot. It will be as hot as it is on the inside, whatever the detector temp is set to. So I need to put this in here without burning my fingers. So what I normally do is I'll take 2 hands, and I will rest my left hand, in this case I am the lefty for this, I will rest my hand on the GC, and then I will push this syringe through my fingers, like I don't know if you can see the needle through, but I've already got my fingers wrapped around the needle. I will hold my fingers right up next to the nozzle, and I will slowly push it in while holding it as straight as possible. You can't do it like this. You have to have some kind of hand on the needle, otherwise you will break the needle with as little force as possible. Now, when you actually do this yourself, you'll have to actually do it yourself to understand what I'm saying. But you're going to feel a little bit of resistance at first. That's the rubber septum. You have to push through it. It's going to go through relatively easy. You just push on it until it starts to go through. And then it'll go through easy. Now, once you get closer to the end of the needle, you're going to feel greater and greater resistance. Then you need to stop. At this point, you're all the way in the GC and you're actually running into something else and you need to stop. Now, supposing that this actually had something in it, I would now have it in here and it's ready to go. I just haven't injected it yet. Now, your partner would have already set away and they would get ready to start the GC recording when you're ready to submit this in, when you're ready to push it in. So, at the same time, somebody would take this little piece of plastic right here that's connected to the computer, and this is what can start taking information from the GC. You can do this two ways. You can hit the start button right here in the window, or the start button here. They're identical. These windows are identical. Or this will do the same thing. And so that's easier. You can have somebody stand away and press the button at the same time. Normally people say 1, 2, 3, push, or 1, 2, 3, and push it at the same time. But the important thing is that this starts recording at the same time that it is injected. Otherwise your timing is going to be off. So, like we said a second ago, we would have had this here, ready to inject something. And then we had somebody standing off to the side with this. We'd say 1, 2, 3. They'd press the button, and then we'd also push this inside, all of the fluid into the GC, and then draw this back out, and then just leave it. And so this will automatically start taking your information. If you've got any components in there, assuming that your syringe is not clogged, it will start to go through, and you will see some results coming up on the screen. And so what we've got over here, so over here we have an example of a GC that's already been run. So I'm not sure what ran through this. It was most likely probably one of the mixtures that will be ran tomorrow or whenever you guys come to lab and do yours. But it will look something like this. Often it will be simpler if you have one particular product going through the GC, but it's going to look something like this. You have time on the x-axis and you have voltage on the y-axis, and then based on the stuff that's coming through, you will get some kind of record that comes in and produces on here. Now, this is automatically set to run for 10 minutes, and it can be changed. You can make it run longer if necessary to run longer, but most of the time the stuff will come out early, and so you can choose to end the chromatograph early. In this case, I want to say that this is the mixture. So what we can see here is that the last product that came through was at about 7.5 minutes, and it tapered off by just past 8 minutes. Now, these last 2 minutes over here have no extra information to give to the GC, and so we could have theoretically stopped it right here at like 8.25, 8.25 minutes, 8 minutes, 15 seconds. We could have cut it off and then saved the rest of the time. You could probably do this tomorrow in an actual research if you don't know when this is supposed to be. You'd obviously wait for as long as possible to ensure that everything is passed to the GC, but we can most likely cut it off at 8.5 minutes. Now the problem with this is over here, the same thing was run, or at least I believe that this is the same thing. It'd be something similar. Notice that the timing is different. This over here says 6.4 minutes. Well, this is consequent of the particular settings that were used for this GC on the left versus the one on the right, so nothing is perfect. You're going to have to keep an eye on the stuff that's coming through to verify if it's at its endpoint or not. And so had we stopped over here, say that we use this as our reference and we stopped at 6.4, well, we would have missed this little hump over here at 7.4 because we thought it was done too early. So we'll have to keep that in mind whenever we're actually running the GC that you're going to be running it on, how long it's set and how fast it runs things through. So after this is done and you've got all your information, you can choose to print it. Just use the regular print button. And I've got an example chromatograph over here somewhere. Find it. So this is an example of a printed chromatograph that come out over the printer over here to the left of all these GCs. And so it is identical to what you're seeing on the screen. Of course, the proportions are a little bit different, but all of the information is down here, and it tells you all the heights, all the areas, and then it automatically does your integrations for you. It calculates the area underneath so you can figure out your percentages of the stuff in the sample. And so this will do most of the work that you need to do. The name up here you can change for yourself. You can add all this extra information whenever you're preparing to print, and then once you're done, you will have this information for you to take off and go somewhere else. You will need to collect the information about the GC before you leave. In these little viewports, it will tell you what temperature things are at. In this case, it's most often set to the detector temperature. So in this case, if this were on, it'd be somewhere up in this range. I think. Yes, it'd be somewhere up in this range for the detector temperature. And then you could change it to take all of the other temperatures for like the column and the injection port. And then you have to record all this data to prepare for your laboratory report.